Hi everyone, my name is Vadzim Varabyou, and today I will be talking about metaprogramming. This is a technical talk about writing code that writes code for you. So who exactly am I? I'm a professional C# developer since 2011, and in game dev I work since 2013, that's 12 years? Yeah. I'm also mentoring in a few bootcamps and help new people to learn the tropes in coding and become a better game devs. Currently, I work with PAPAYA. It's an Israeli-based studio, and we create mobile games, competitive mobile games. You might not find them in the store in Poland. We mostly work with US, but they're still very cool. And a bit of foresight about what this talk is going to be about. So first of all, about what the hell metaprogramming even is and how we got there. Then I will share some practical stories, how we use it with C# and talk about Roslyn generators. And also, I will talk a bit about the problems that we have outside of C#, and that will be a bit about the Apache Thrift. So, as you might have guessed, this talk is mostly useful for Unity developers. I hope, by the raise of hands, who is a software developer in Unity engine? Okay, so nice amount. What about other engines? Okay. I hope you will still get a bit of inspiration at least. And this talk, as you might guess, is not exactly about Unity, it's more about C# in general. So after the talk, please catch me. Let's start, shall we? A brief history. So first of all, metaprogramming, how it's different from your regular programming. With regular programming, you get your source code, and you build a program that takes data and outputs some data. For example, you give it a prompt of give me a picture of a cat, and you get a picture of a cat at the end. With metaprogramming, everything's the same, but as input, it takes your source code, and as output, you also get a source code for another program. And that is very useful because you can write less code. That's what it boils down to. First, this idea came in Lisp in 1963, and the author of the language just went, OK, so how can we write less code? Well, let's allow the language to change what is written while the program runs. He invented Lisp macros, and it was a big success. In the 1960s, computers were big. Only big companies have them. Runtime performance was not important, and time spent writing software was kind of important. That went well. So in 1991, C++ and templates came out. Those who don't work with Unity know that well. With templates, they are basically black magic. They're not magic. They can be tamed, but it's not exactly easy. And they allow you to write a lot less code than if you didn't have them. That also generally went well, but in C++, it was notorious for long build times and poor maintainability. It was kind of hard to deal with templates if something goes there. In 2000s, this idea transferred to C#. C# was invented, and C# had those three things. It has reflection, it has just-in-time compilation, and it has intermediate language, basically like virtual assembler. And what it allowed is to have code weaving, and it was a technique to add code to your app, to your program in the runtime. It was 2000, so everyone was going to web. It was very cool for using with databases, and it worked. The performance is very excellent, but the problem was even worse than with C++ maintainability, because when you have code without the sources, it's absolutely impossible to debug it. So next, Microsoft invented T4 templates, which was basically a version of PHP. You got, version of PHP in quotes. You could create a template of the code and then ask the T4 tool to fill it with some data from C# assemblies that you had. If you remember, at this time, Unity, I think, just started its existence, and it has this folder called Preworm, I think, where you could create some code that was built first, then processed, and then you had your final assembly C#. I did a talk about that back in the day, I think 8 years ago, and it was a very nice tool that helped me at some point to work with network. So if you're interested, we can expand on that, but we don't have a lot of time. To the chase. Next thing that was invented is the Roslyn compiler, and it was a big invention to make things comprehensible. Roslyn compiler compared to regular C# compiler is like a transition from built-in pipeline to URP. Previously, compiler was a black box. Now with Roslyn, they provide you all the tools and all the access to actually extend the compiler. Starting in 2020, one more thing was added, Roslyn Analyzer, so you can have improved version of Roslyn. You have your ability to actually go to code and read all the text from it. And starting in 2020, Unity actually supports it in their build pipeline, which is very nice and what makes this talk available. And I just got yesterday the message from JetBrains, their new version of Rider will support it in IDE. So never had a chance to update the slides, but the tech advances rapidly. And since our theme here is about the future and things, well, AI is there, it's getting there. Some things will be generated with it, of course, obviously. But two things that you could see from here, between first demo and first release of some technology and actually industrial application, sometimes 10 years can pass. So if you were, for some reason, worried that AI will take your jobs, not in the next 10 years at least. You have enough time to prepare and to master it. OK, so next we'll be talking about Roslyn specifically and how it is useful. In a lot of ways, mostly for not writing the boring code. Some might say that all code is boring. That depends. Here's one of examples that I guess everyone who written pooled objects have struggled at some point, right? You need to reset all the data for reasons, and you work. Sometimes you add fields, and then you forget to reset them, and then you get bugs in production, which are very hard to catch because they stay in memory, yada, yada. It repeats itself for everyone, and with code generation, code analyzers, you can automate this flow and don't have this headache. And you can automate a lot of things. You can automate boring stuff like generating toString. It's a very simple thing to do, but nobody does it, and it's very useful when it's implemented properly. You can basically any type of boilerplate, any place where you have the only one correct method to write things, you could use code generation there and benefit from it greatly. You might ask, OK, I can use, for some things, I can use reflection and do it on the fly. Why do I need to use code generators? And the answer here, of course, is performance. So especially when we work with data, with serialization, with things like that, default solution based on reflection are very slow, and that's usually suboptimal for us. How much exactly reflection is slower? By a lot. So according to this graph from Star Debugging, I think it's quite recent data, and the guy tested it with big JSONs or something. The difference is almost 1,000-fold, so definitely is worth it. Well, quote, Star, check your profiler first, never optimize without profiling first. So apart from that, all things where you rely on reflection basically can be optimized to be created with code generators to improve performance and to improve your life as a developer. Talking about Roslyn, Next, I will show you a small example how Roslyn can actually be used. So first of all, how it works. As you remember previously, Roslyn is a special compiler, not a black box, so he allows you to add custom implementation to any steps. And for us, it will specifically be interesting to change the source code generation step, which is happening after we generate our source code abstract tree, which we do after the compiler reads and processes all the text inputs, so quite early in the process. Here is the link to a sample project, courtesy of my colleague provided. His name is Yuri, a great engineer. He's in Israel, so he's not here today. How does it work? First of all, code generation is not a part of Unity project. It's a separate thing which you create, which you then install into your Unity project, or it doesn't have to be Unity. If it's C#, it will be supported. Technically also BASIC, but nobody makes games in BASIC, so it doesn't count. And when you have it, you build it, you add it to your project, you click some checkbox according to Unity manual, changes from version to version, and then in the end, you get your code created with the assembly C#. The setup is pretty straightforward. So first of all, you need to create a new .NET project. It's going to be a library targeted for .NET Standard framework. And you will also need to install a nugget, which is code analysis C#. Unity currently supports, I think, 4.3. If you use it outside of Unity, the latest version, I think, is 4.9. So it's quite ahead of time, as we're already used to in Unity. No worries there. And after that, it will add a library to a project, and you can start working. So what you need is a interface, our source generator. We have two methods. Please excuse the braces error. I was doing that late at night. And an attribute of generator. With that, second thing we do is we create ourselves a small template. What the project will do. It's a simple tool that creates an enum extension that has all the values in enum as a list, right? Simple thing, yet powerful, allows you to have a little bit better quality of life. Good enough, for example. So for that, we create a small template. This syntax is arbitrary. We just used to use double braces here, but it can be anything. It will be replaced by string replace in the end. The reason why we use this type is because it can be used with interim strings, the one you start with the @ symbol. After that, if the code isn't like big enough for you to read, don't worry, the QR will be at the end as well. We get this template. This time it's been an embedded resource, so we get it from assembly, get manifest, load it, and return it as a string. Nothing fancy. Then in the execute method, in the generators, what we do is we say, OK, get us all syntax trees, and from those trees, give us all the enums. So we are looking specifically for the root syntax trees, which are your classes or structs or records, anything top level, not nested. From that, we get descendants nodes, which are, so roots are namespaces, then we get descendant nodes, then we get enum of declaration syntax, and that's how we get all the enums in the project. Next step for us is to create the thing itself. So from the syntax tree we collected, we get all the data that we need, the namespace, the enum name, the enum values, and this is a pretty straightforward thing with all the comments. After this, this is part 2 where we actually get the data, and then we fill the template with the data, where we just, as I told you before, replace the things with the values we've collected from the syntax tree. And that is it in a nutshell. This code will be introduced to the assembly, and you can just use it in your project like it was there. It launches, it's fun. Works great. You can follow the QR and check it yourself. And there will be a bit more stuff, since we have not so much time today, about how we could improve it around. The biggest thing to improve is to add custom attributes and only process marked types, because that's usually a good thing to do. And of course, if you use it in real production environment, there is a lot of contained work, like you want to have this project being part of CI, and you want to have documentation, you want to have it in Git, and all those things that we could skip. And the best thing here is when you create your generator, it's portable, right? So it doesn't have any dependencies to your code. It's a known thing. In fact, when you import it to Unity, Unity will have, your Unity project will have a dependency to this generator code, which really simplifies things. So that means that there is a lot of free real estate there, and I want to highlight some very nice projects, open source, with MIT or similar licenses that you could use. One of the best ones I could recommend is a vContainer. It's a DI framework built with code generators, which is really fast and really nice to use. All those things that are marked here, yeah, they're all number one, I guess. Num generation saves a lot of time. Auto-generated clone, absolutely invaluable when you work with data from backend. Data builder allows to create views for models more or less automatically. I think. Then there's also this link again, which helps to create a link queue that doesn't allocate memory, which is also good for Unity because memory spikes is a thing. Generator equals is an automation to unit code generation that helps you with creating equality and hashing, also very nice. Then there's fast generic new. If you are not using DI, this one could be a lifesaver because it simplifies creating generic classes for you. I hope you check them out, and we really have enjoyed working with them, so advise very much. But C# is not the only thing that gives us problems, since most of the games, all of the games PAPAYA is working on are live op games, and you know what happens with live op games. There is a client to backend interactions, and this is fine. Most of the time, most of the problems with those kind of games, if you worked on them, are because versions don't match. Backend version doesn't match the client version, something was updated too early, something has to be reverted because there's errors. There's gradual rollout in the store, so we have to support both versions, but we didn't test them, so a version breaks, so we need to force an update, all kinds of things. And even in development, sometimes you need to fix the backend before you can update the client, and you need to fix the client before you can update the backend, and nobody knows to do. And honestly, I don't think there's like a way to solve it, right? But there are numerous ways of making it easier and manageable. And what we find is really working for us is Apache Thrift. Apache Thrift is a tool, I would say a domain-specific language, created by Apache, obviously, which allows you to generate your network APIs, and basically does it for you, right? So it creates code for you, technically metaprogramming. How it works, you create a Thrift descriptor for your service, and then you run the tool, which will generate the code for you. Here is an example of a data package which we actually use. It was approved, no breaking NDI anywhere. It's very simple syntax. You declare your structures, mark fields as mandatory or non-mandatory. It supports all sorts of containers, lists, dictionaries, custom types, everything you need, and is actually very nice type support compared to Protobuf, for example. In the same Thrift, you can also declare the APIs, the RPCs that you will be calling. We don't really rely on that because Unity Web Client is not a default C# solution, so we had to just create our own, but technically it's almost the same. And when you have this generation, the Thrift creates classes for you which look absolutely robotic, and that's kind of the point. But they also are very simple, no reflection, very fast, and they work, which is the most important thing in our work. So how does it help us? Quite a lot, right? So every time when something is changing on backend, we don't have to go and to reinvent all the client, and we don't usually have a lot of breaking bugs, and that's because we taught our backend guys to actually work with obsoletes, and if they break something on backend, how do we maintain the generated code? The keyword partial is very important. People use it for various things, but it was designed to be used with generated code, and if we change some API, we provide a placeholders, and then we have a non-breaking changes we can merge into our Git. And after that, client devs can update slowly at their own pace, and it generally works most of the time. And I think that's it. Thank you for listening. If you have big and interesting questions, please contact me on the LinkedIn. If you need code samples, they're here, and the slides are also here. And I hope we have enough time for questions.
Hey, yes, we should have enough time for a few questions. Can I start with what is an integer, or should we? No, I'm joking.
Okay.
Anyone? Raise your hand.
Hello. I'm not a developer, so maybe it will be a dumb question, but still. With all the trends and all the rage about the AI and generative AI making it easier to apes like me to basically do the engineer's job, are there any trends or any movements within this topic about further advancing it with like LLMs and such?
So specifically with LLMs, I don't think so, but there are way more to AI than just LLMs. And most of the tools, using metaprogramming is only one of ways to generate a code for you. Another most popular is actually using the IDEs themselves, right? So if you use Rider or Visual Studio, the bigger IDEs, they have a lot of built-in code generation things for you. You don't have to write some things, like for example, if you need to write an equality operator, you can just use a shortcut for that, and it will generate it for you, always the same. It's a pretty nice thing. But you still have to actively do it, right? With this approach, you can automate it and have it done for all the code that you have in your repository, which for some implementations is better. Regarding the AI will definitely be improving the tools. So most IDEs have AI support in there already, and there will be improving. But AI, it's like more exploratory, right? So every time you ask it to generate code, it generated slightly different. It's good for certain implementations, right? When you are trying things out, and it's a very powerful tool for that regard. Metaprogramming is a bit a different concept. When you want your code exactly the same every time, and when you want it like strictly like this with no changes, it is a better tool, and it is reliable in the sense that every time you use it, it will give you the same result and it will maintain consistency. So, short answer, yes, there will be a lot of more advancement in AI, but in a slightly different area of engineering.
I see, it helps a lot, thank you.
I would like to ask which main goals I bring in by this approach. I mean, if it better, if for example we just copy class and just how to say I mean without this solution. I mean, or maybe create parent class with some implementation and make some child class, something like this. Why it better if we compare with obvious normal coding way?
Okay, that's a nice question. So with usual code, when you work in a company, in a bigger one with a lot larger code base, sometimes the idea of what a good code is, it changes, right? And you have, like in every project, you have some parts of obsolete code and some parts of code that is no longer up to standard, but it is too costly to improve it. It's somewhere in the technical debt area, and later on, you need to just go there and do some manual work to upgrade it, right? If you had 10 copies of more or less the same thing, and then a new solution architect arrives at the company and decides to change things and improve them, you need to go and change all the tens, hundreds of places in the code, and that might be quite a task. So when you have systems this large, you can say, okay, so this is how a good code should look. We can templatize it, and we can create a scripts that will do it for us. And then if some changes appear, like for example, you need to implement iTeachable now for every class that you had because you moved to a DI container. Well, that's kind of a bad example, but you can, with templates and code generation, you can do it quite fast for all the places in your code without manually having to work days or weeks for that.
Okay, thank you.
Okay, I think we're out of time here, so thank you very much, Vadzim. It was great.
Thank you, everyone.